Welcome guys. Today we are going to look at a question on surfing, and the question is already given. We are supposed to reduce the repos in rise and fall method, and also we look for the gradient. So the question is given and it reads that the following readings were taken with a repo and a 5-meter referring stub at a continuously sloping at 25-meter intervals, and then we are given the readings from 0.680 to 4.878. Then the question reads, rule out the page of a repo book and enter the reading. Then reduce the repo by rise and fall method. And then number B is that determine the gradient of the line joining the first and the last point. So automatically from the question we can see that we are supposed to use rise and fall method, and for that one we have to tabulate our data. The table is already here, and you can see that we have different stations as per the data given. So from the data given we have the first reading, that is 0.680, and we automatically know that in rise and fall or in surfing work the first reading is always a backside, and that is why we booked here the 0.680 as a backside. Then the last reading is always a foresight, and you can see we have a foresight. It is already here as our foresight, 4.878. All the other data between 0.68 and 4.87, they are all intermediate site because we don't have a change point. So all the other data, they are intermediate site, and you can see I've recorded them here as my intermediate site. So meaning I have data from number 1 up to number 11. That's where I have station 1 up to station number 11. Then I'm told that the reading is the sloping at interval of 25 meters. So we have 20, after each 25 meters we have new station, and that is why I have the first reading as 0, station my 0. Then the second reading is 25. Third reading is 25 plus 25, 50, which then the third reading is fourth reading is 50 plus 25, 75. Then 75 plus 100 up to the end. So you add 25 to each, and then meaning that the last reading in our last station will be 250 meters. So the chainage is from 0 up to 250 because the interval between each station is 25 meters. So with this we can be able now to reduce the repos because I've already booked my back site and also the intermediate site and also the forward site. So we are going to deduct back site from intermediate site, and then intermediate site to the intermediate consecutively up to the end. So we start with 0.68, we deduct 1.725. So that is 0.680, we deduct 1.725. This is a negative 1.045. Anytime we get a negative, that is a fall. Anytime we get a positive, it is a rise. So this is a fall of 1.045. Then the second one is 1.725. We deduct 1.956, and this one will give me 0.231. And then the next one is 1.956. I deduct 2.730, and this one is giving me 0.774. And then the next one is 2.730. I deduct 3.685. This one is giving me 0.995. Then the other one is 3.685. We minus 4.985, and this one is giving me 3.685. I minus 4.985. I'm getting 1.300. Then the next one is 4.985, 4.2. So it's a positive, so it is a rise. And this one I book it as 4.200 into 3 decimal places. Then I have the next one, 0.787, deduct 1.467, and this one is giving me a negative of 0.680. Then I have 1.467, I deduct 1.985, this is giving me a negative again of 0.518. Then I have a negative again of 1.985, deduct 3.785, this is giving me a negative of 1.800. Then the last reading is 3.785, 3.785, you deduct 4.878, and this one is giving me a negative of 1.093, so it is 1.093. So with this I have the data for rice and also the data for the fall. So I have to reduce the repo, and from the example, from the question, we are given that the reduced repo at the first point was 20.071. So at the first point, we our repo is 20. Our new repo, the first point, the repo that we have is 20. We have 26.071. So with this, for me to reduce the repo, it's just very simple, because I just need to take the reduced repo, I subtract 4, and where there is a rise I'll add. So automatically it is 2026, I subtract 0.071, I subtract 1.045, this is giving me 2025.026. Then 2025, I subtract 0.231, this is giving me 2024.795, and then 2024.795, I subtract 0.774, this one will give me 2024 again 0.021, and then I subtract 0.995, this is giving me 2023.066, and again this one I subtract 1.3, that will give me 2021.766. Now I'll add to 4.1 because this is a rise, so it is 2021, you add to 4.2, this is addition, so automatically 2021 minus plus 4.2 will give you 2025.966, and then I subtract again to 0.680, you get 2025.286, then I subtract again to 0.518, you get 2024.768, and then I'll subtract again to 1.08, this is giving me 2022.968, and again I subtract the last one, and this one will give me 2021.875. So that is the reduced repo. This is the first station, so this is point A, or remark is at point A and this is at point B. With this I can have summation of backside, so I can have summation of backside. For the backside I have 0.680, and then I have summation of foreside, which is 4.878. Also I have summation of rise, so this is 4.2, 4.200. I also need the summation of 4, so I have to add 1.045. I add 0.231 plus 0.774 plus 0.995 plus 1.3 plus 0.68 plus 0.518 plus 1.80 plus 1.093. This is giving me 8.396 is my summation for the phone. So we can have the arithmetic check. Arithmetic check. Arithmetic check, and on the arithmetic check, we usually know that summation of backside, minus summation of foreside equals to summation of rise minus summation of 4, which is equals to reduced rainfall last, that is last reduced rainfall minus first reduced rainfall. So this is first. So with this I can fit the data that I have here already. The backside is 0.680. I will deduct summation of foreside, which is here, which is 4.878, 4.878, and this one should be equal to summation of rise, which is 4.2, minus summation of 4, which is 8.396, which is equal to reduced rainfall. Last reduced rainfall, it is 2021.875, 2021.875. We deduct the first reducing rainfall, which is 2026.071. It is here the first reduced rainfall. So with this, for the first one, let me see what I'll get. This one will give me 0.680. We deduct 4.878. This one will give me negative 4 equals negative 4.198. This one will give me 4.2. We minus 8.396. This one gives me negative 4.196, and then this one too will give me 2021.875. You minus 2026.071. This one will give us negative 4.196. My data are the same, so therefore it is okay. This is okay. Arithmetic check, it's okay. So I've done the ruling. I've also done the arithmetic check. So what is remaining is the gradient, which is my number B. So for number B, the gradient, remember, gradient is always given by change in y or for change in x. So if I already know that I have change in y, so what we mean is that for gradient I'll be given by vertical distance we divide with horizontal distance. Remember, this is automatically as we usually do in mathematics. So we have change in y or for change in x. So this is y and this is x. So this is vertical distance y and then over x. So what we need to have is our vertical distance, which is given by reduced level of 2021, and it is my highest point 2021, and then we have 2026.071. So change in y over change in x, I'll just take my first reading is 2021.875, it is here. Then at the top I have 2026.071. that is my vertical distance, meaning I'll just take 2021.875, I subtract 2026.071, everything I divide with the horizontal distance. My horizontal distance is from 0 to 250. So the total distance is 250. I'll just put 250 here. So already I have the answer for 2021 minus 2026. It is here, which is negative 4.196. And for this case now I will know the negative. So I have 4.196. I will ignore the negative. Then I divide with 250. So which is the same as 4.196 in to 250. So in this case I can just say 4.196 into 250, and I make 4.1, I divide everything by 4.196 on both sides, 4.196. so this is common, so I have 1 is to 250 divided by 4.196. This one will give me 59.666, which is the which I can just say that it is 60. So my gradient will be given by 1 is to 60, and that is the gradient for the surveying work. Thank you, and kindly subscribe to my channel.